TCP acceleration to make your cloud connections faster. And we have Greg Gum, who is the CEO and co-founder of Virtuosity Network, a cloud PaaS provider. He has over 25 years of experience in telecom and networking. He's a Wharton graduate and is an AWS cloud practitioner. And on top of that, he's the most regular, one of the most regular, not the only, one of the most regular attendees of our meetup. So big hand for that.
Thank you. Thank you. So I'm just getting my voice back, so just holler or raise your hand if you can't hear me. I'm with Virtuosity, so I'll try to be fairly quick since I'm standing between you and probably home or that beer and wine over there. So just a quick show of hands. How many of you are actually like doing DevOps or software engineering? Oh, mostly everyone. Okay. Okay, good. Any CCIEs, networking specialists? No? Okay, good. Okay, so I'll try to hear it appropriately. So Virtuosity, we're a seed stage company. We're based in Pleasanton and Dallas. We basically develop software and platform as a service solutions for enterprises, CDNs, cloud providers, and mobile operators to accelerate your WAN connection or your cloud connections. So our whole vision, if you take a look at our slide, is I've been in the WAN business as a carrier and also as a number of startups. And the internet still is unfortunately what we see to the left. Even though we've got all these improvements in bandwidth, infrastructure, we still have congestion, just like 680 at 5 o'clock. What our goal is to be what the picture is on the right, using our congestion control algorithms and software to help improve the traffic flow. So if you think about these cars and now your packets, and how your data gets from one place to another depending on your applications, we want to basically be able to have the autonomous driving vehicle software for your network connection. Okay, so with the agenda, I'm going to talk a little bit about some reasons why your internet or your cloud connection can slow down your apps. Since you all develop, that's obviously critical. I'll talk a little bit about some good, bad, and ugly reasons about TCP, good reasons as well as bad reasons. And then I'll talk about some optimization techniques that are software-based that don't require extra hardware that can make your cloud applications run faster. How and why it works, and then I'm going to actually turn it over to Chris. I'm going to introduce Chris Arkin. He's my digital marketing manager, formerly from Apple, and he'll actually give you a little demo of how it works so you can actually see it running live to the Oracle site. We're actually using the Wi-Fi. Then I'll talk a little bit about the pros and cons of our cloud implementation. So we provide both platform as a service for public cloud, so you have public cloud offerings, and we also have on-premise solutions where people license it. So one of the things that I was asked about the last couple times is, can you talk a little bit about why you chose Amazon? We're an Amazon partner, but we also use Azure, we also use Google Cloud Platform, and I'm also going to try OCI with those nice $500 of credit and the $50,000 of Velocity, which is a good thing. Velocity, I like that name, so that we can see how our images and instances work. And then Q&A. So what's the problem? Well, how many times have you seen the spinning wheel of death, or you're downloading, a video, you're watching the Warriors game, and you get this stuttering, right? Or you try to back something up, and it's going to take forever, right? Not only is it frustrating, but also it can be very, very important, because if you take a look at some of these studies, an Amazon study showed that almost 2/3 of people found out that slow response time really matters when you're talking about online transactions, and online transactions make money. So if you take a look at this chart, you've got abandonment rate going up in percentage, and you have startup delay in seconds to load, let's say, your page. And as you can see, these different lines are the type of connection, whether you're going over fiber, cable, DSL, or mobile. So the bottom line of this is, it seems like mobile users are more patient. They're more willing to tolerate a longer time, probably because we know, hey, geez, your mobile network's gonna be slower than your wire, right? So you can see fiber, of course, boy, even before 10 seconds, they're banding, they're dumping. Same thing with DSL and cable to a lesser extent. So it really does. Speed does kill, and speed matters. An Amazon study also said for every second of delay, that's a 7% drop in online sales conversions. So just think about that, 16% drop in satisfaction. So not only do you not make people happy, but also you lose the sale. So you think about all those millions of dollars that can happen for every 1 second that you can save. So one of the reasons for slowdowns, network congestion, right? So if you take a look, there's your 680 again. Network congestion is the reduced quality of service when a network is required to move more data than it can actually handle. And there's a lot of reasons for why that can happen. Some of the causes and signs are you might not have enough bandwidth, maybe you've got a skinny connection, maybe you're getting packet loss. You could also have network jitter, like on a mobile network, or delay due to distance or where you're going to. You could also have user mobility. So if you're going 70 miles an hour down the highway, that could also cause jitter. ISP oversubscription, you might just have an inefficient network connection. Maybe your wireless router isn't configured right. You might have a router in your path that is buffering incorrectly. You could also have poorly performing appliances. Maybe your firewall isn't filtering correctly. Also, maybe the router in one of your hops is also has a problem. So there's also just increased application complexities, right? Our applications are getting fatter and fatter, bigger and bigger. We're now relying on going up to the cloud and getting things from the cloud. We're not running things locally anymore. So that complexity also causes a much more strain on that bandwidth connection. So what can you do about it? Well, you could buy more bandwidth. You could build your own network like Oracle did. They said, hey, we got to build OCI. We got to have a fast network, right? Can't rely on others. You can buy faster routers and servers, but that costs money. No one wants to buy infrastructure, like you heard from the guy from Santiago, right? He's going through a hardware refresh. He doesn't want to pay all this money. He doesn't have any money left over. You can also cache. So I heard someone ask about Akamai. Well, you could use caching services like CDNs. You can also do even edge caching, which is now the new thing, to get closer to the customer, store the material, and then be able to accelerate it. You can also use SD-WAN. So Oracle just bought Tulare. Tulare is an SD-WAN provider. Software-defined WAN routes your packets in the most optimal path. So it looks at the path and says, geez, I've got some congestion there, go another way. All right, so they do that with software, so at layer 2 and 3. You can also DNS steer. You can set it up so that you can go to, it finds the closest DNS server so that you get better results for your website. You can just do better, efficient web design, right? Build better code, right? Just live with the internet as it is, which is best effort, which it doesn't really do you much. So what do we do? So today I'm going to talk about TCP IP. I know it's a really mundane topic. It's been around for a while, but how TCP IP and specifically TCP congestion control can be a software mechanism to help you accelerate your applications. So everyone's heard of TCP IP, right? So I don't have to go into it. We're going to the stack. But effectively, I think the thing I want to leave you with is that TCP IP was built by DARPA for ARPANET, back in the day, to really have reliable connections. So it was really there to ensure that you send something, you got it on the other end, because it was for the government, NASA, etc. So it's highly reliable, and that's why it still stands the test of time. The second thing is it has to be interoperable, right? So it has to be useful across different OSs, different types of computers, network hardware. So pretty much now de facto, all the traffic is pretty much still de facto TCP protocol. Even today, even after since the 70s. Now to distinguish from that, what is TCP congestion control? Well, TCP congestion control is actually a feature set in the stack that allows you or ensures that the sender does not overflow the actual network. And of course, you can see why that needs to be managed. If everyone just jumps onto the highway all at the same time, just like you're on 237 trying to get on, and geez, you're just stopped, right? Because everyone's trying to get onto the same place. So it provides algorithms and techniques that allows you to prevent some of that congestion and also help mitigate it when it occurs so that you can still send your data through that connection. Okay, so just to give you a quick highlight, and I won't go into too much detail, but this is actually what actually happens when you're sending your data. This is the actual default qubit that's used in Linux today. This is the algorithm that's used in most of the Linux distros. So you can see you start to send your data, it starts to ramp up, right? And then as you reach a state where it's moving fine, you don't see any packet losses, and then it will increase the window size and it'll start to probe, find more bandwidth, and start to go up again. Problem is what happens if there's packet loss? Packet loss, man. Something happens, something in the network, one of those things that I told you, causes your network to slow down. Well, what does TCP/IP do? Immediately tells it, whoa, slow down, back off. Send me an acknowledgement, tell me to slow down until I can start to resend again. Okay? So remember how that will then happen. As you're going along, you're going to get these kinds of peaks and valleys or these concave events. So further, how does it work? As I mentioned, a good analogy is like an on-ramp, managing an on-ramp onto the highway, right? You're all trying to get onto the same place. You might have multiple people. You're the red cars. You're all trying to get in there as you're trying to look for those slots. So you want to be able to monitor the current traffic. You want to be able to identify where there's capacity, where those openings, and then maximize the sending of those flows, or in other words, getting those trucks or cars onto the highway efficiently, and to optimize your efficiency, and particularly when there's a lot of congestion like this. So, the way TCP works, or congestion control works, is it actually lives within the Linux kernel itself. And because it's in the kernel itself and resident in the stack, it runs as very efficiently and also very secure because it's actually running within your operating system. Okay? And it constantly will adapt to these packet losses and delays and retransmissions, which then gives you a better availability and then manages those resources in a more fair way. So that's the theory. So TCP congestion control has been around since the 70s. There's been probably, I'd say, at least 50, 60 different types of protocols used. There's a number of them. So what's wrong with those, right? Well, part of the problem that's wrong about it is that they were built for those reliable networks back in the 70s when basically 1 meg was darn fast. In fact, I don't know, maybe since, I don't know, how many people are over 30? Okay, well, most of us, right? So we probably remember 9.6 modems, we remember that, we remember about slow connections, going to broadband, right? All those types of things. So those protocols were built for high reliability, not performance. They weren't running on 10 gig fiber networks. They were running on 5G or even 4G LTE, okay? So what the new algorithms do is they now accommodate not only reliability, but also scale for performance. And so why do these new techniques work better? So just to give you a quick highlight, native Linux uses things like qubit, which is the default in most Linux distros. CentOS, Ubuntu, Amazon Linux, Oracle, it's resident in your Windows platform now, it's resident in Apple iOS. That is what they use as the default. There's also Reno, Tahoe, and many others, okay? The issue is anytime there's network appearance, particularly packet loss, those algorithms do not do very well. And they have to wait for acknowledgements to then ramp up again, as I mentioned in that earlier chart. So here's what happens. You end up getting a very sawtooth-like pattern, right? So if you do packet captures, if you're doing T-Sharp, Wireshark, or whatever, monitoring platforms you've got, you'll see it'll start up, it'll be working fine, then all of a sudden you get an incident, drops that down, has to ramp up. So you get this sawtooth effect. So what the newer algorithms do is they basically start and pace it much higher and optimize the network for the maximum capacity of the network. And so with some of the new algorithms, particularly, of course I'm biased, so I'll talk about VLN, which is our software. We actually use machine learning. So we dynamically learn the connection's capabilities, and then we adapt to the network conditions in real time. So we're constantly pacing that up here and looking at how much availability is there, if there's packet loss, what we can maximize it to. And so thus you get this difference in performance, And also you get, if you notice the line, you get a much smoother line. So you don't get all this jiggy-jaggy sawtooth type of impact, which can, of course, if you think about it on your video, that can really hurt it. So we basically then look at those connections, and then we dynamically can monitor and manage that congestion in real time. So what are the impacts and benefits? So what's in it for you, right? Well, you can increase your speed up to 80% or more. In fact, in some cases, I just got done with a network in Eastern Europe where we saw over 200% improvement on their network connection because they were highly oversubscribed. They were running on a mobile infrastructure, 3G, 4G conversion, lots of congestion, lots of packet loss, lots of jitter. So depending on your network conditions. But even then, even at 80%, that's a lot of improvement. So you don't have to buy excess bandwidth. You don't have to upgrade to more pipe. You don't have to buy a direct connect from Amazon, right? Or you may not have to. You don't require expensive hardware. So as I mentioned, you don't have to put in special appliances, like Riverbeds or Cisco's or Palo Alto's. There's no booking ending required, right? So a lot of these solutions, you had to have one end on each matched, or you had to have an agent down at the premise and then have it matched. We can do it on a one-ended basis. We work over any kind of media, copper, fiber, DSL, 3G, 4G, 5G, satellite, doesn't matter. And it's also a very small footprint, and it has to be because it's running in the kernel. It's running in your operating system, so we cannot add additional latency, right? Other than what you're running on your operating system. And it has a very low CPU and memory requirement. So that also allows you to put it into very small devices. In fact, later on, I think Chris brought one, we actually even installed it, it's running in a Raspberry Pi, $20 Pi. It can still accelerate, right? And then with our cloud, we cloudified it, we put it up on Amazon. We also loaded GCP images and Azure PhDs. You can essentially then work wherever you want it and whenever you want it. You turn it on, you turn it off. You can apply it to your workload when you need it. When you don't need it, shut it off, right? So you're basically, we have a cloud native, or you can actually put it on your premise and run it on your own infrastructure. So where do you use this software? So I mentioned we have a cloud instance. You can go click on Marketplace, or you could go on OCI Marketplace. We load in there. Google Marketplace. You can then spin it up, apply it in instance to your workload. Away you go, right? Or you can also license it, put it on your own premise server, right? Your own data center, rack servers, and manage it yourself. And then also, you can also provide it on the endpoints. So if you want to not only do downstream acceleration to endpoints, you can also do upstream. We have an Android OS version as well. And we can run on pretty much any kind of Linux platform. So even PCs running Linux work fine. Could even potentially create an access point. So with that, rather than go into more details, I'll let Chris run an actual demo so you can see what is the impact of running this software. So Chris, I'll take it away.
Okay, thank you very much. All right, where's our
Yeah, you just
in the era of dongles.
yeah, that's unfortunately one thing we couldn't virtualize. So no virtual dongles.
You never know.
There you go.
Someday, yeah.
So as you do that, this is actually on our website. So if you go to virtuosity.io, you can actually download it yourself from your own PC or device, and you can try it. So you not only see the download speed as it's downloading to you onto your machine, but also when you run the little video thing, you can also actually have it run in your browser. So what Chris is going to do is he's going to give you a little demo of this.
Sure. Yeah, so if you go to our website, this is, you'll be able to run this live. Let's see, download this. All right, here we are. So the video on the left, this is being hosted live right now in AWS Virginia. So it's being streamed right here as we speak. And the video on the left is the default qubit congestion control that Greg was referencing. And on the right is our video with our VLN cloud congestion control. You can already see this is an HD video. You know how we're still stalling over here on the left. 16 seconds in or so. We're already 30 seconds going on the right side.
So this is actually live streaming over Oracle Wi-Fi connection to his Mac.
Yep, exactly, from Virginia, I believe, yeah. And feel free to try it on your own computer, at home, anywhere. This is, for discovery of what's going on currently with your connection. I'll give it a try. I was having a hard time doing the cloud to cloud earlier when I was or before this talk. So bear with me if it takes a second.
So what he's actually going to do now is we have 2 cloud servers running up in AWS, one in Virginia, one in Tokyo, and he's got the acceleration software loaded up on each, and he's actually going to be running some iPerf tests from one location to the other, so you can see back and forth. So this is actually going live up singly from the Wi-Fi, but then going up over Amazon server. And this is just a free tier, so it's not you're not cheating. It's no direct connect. There's no, no extra special compute resources or anything. We're just using free tier T2 micro. If you're familiar with AWS lingo, free tier.
And yeah, that might be a little hard to see, so I apologize, but it's about 1.9 meg bandwidth received on the Japan side. This is the virtual server in Tokyo. Over here on the right is the virtual server in Virginia, both on AWS. So we got 1.9 there received, and that was with qubit again, the default congestion control for TCP. So now I'm going to echo, and it's quick command here to enable our congestion control, and we can see if and how much it improves. That's going to run about 10 of them, and then average them out. Not the. Yeah, about 3 or so. Yeah, so for a more technical under the hood sort of demo instead of video, it's showing what's actually.
You got about a 30% improvement that time.
Or less, yeah. Yeah, and there we got.
Now you're at 4. Okay.
Yeah.
Now you're getting 4, so it's even more now.
Sure, and on the following slides that Greg will go through, we've, of course this is just anecdotal right here, but we've done, a load of tests and average them out, and to get, when we talk to customers, we can run demos all we want, but they want data at the end of the day, so.
Oh, that's almost a 56, doubling improvement.
Yeah, over double, yeah.
That's good.
Great, should I turn back to you?
Great, thanks, Chris. No problem. Okay. Oh, yeah. So as they say, sometimes seeing is better than believing, so here's just some, we actually ran, of course, many batteries of tests. So as you can see, this one, VLN is the green one. Blue is the competitor. Actually, this is Google BBR, if you're familiar with Google BBR on YouTube, and this is native Linux, the red. So from the top, this is your throughput, and this is, as you see, increasing packet loss happening. So as you can see from the chart, we're considerably faster than Google BBR or Cubic, and when you run into packet loss, you can see what happens as soon as there's any type of packet loss, 1% or higher, these really drop down quite a bit. So if you're running any congestion, we're still able to provide pretty significant throughput. Typically, 80% or more improvement, depending on your network conditions. This is over wired connections, so this is over a fiber Fios connection, I believe. Yep, running up to EC2 Virginia, running Ubuntu. And it's 65 millisecond round trip time, 50 milliseconds in jitter, so not too bad. Here it is over wireless, 4G. So what happens when you're on mobile, right? So you can see here, these again are live tests. These are actually using an LTE connection up to AWS EC2. And you can see considerable difference over cubic. As soon as you get even a 0.5% packet loss, cubic does not do real well. So for mobile connections, this can be really helpful, particularly as more people are doing more and more things off of their mobile device. So thus we have a mobile operator customer that they use our software for. And here's more of a normal application that says, well, hey, I just wanted to know what would happen if I put it on my Facebook, see if I get faster Facebook. So you can actually see we actually ran this on one of our little, a Samsung Galaxy 7. We took a video clip on it and then we basically sent it up to Facebook. Blue is actually running with Cubic and orange is actually running with our congestion control. So bottom line, as you can see, we had almost a 2 to 2.5 times faster upload to Facebook using our acceleration algorithms. Here's just a standard SpeedSmart test. Have you ever gone to SpeedSmart or any of these websites you can test? We just ran it again from, actually this is running from London to, so San Francisco to London. So you can see, especially on the upload, we actually were just improving the upload because we didn't control the server. You can see we got some considerable improvements. We went from 5 meg all the way to 20 meg upload on your phone. So that's a big difference. So this is a cloud native thing, so I wanted to try to go through, what was our decision when we decided to put our platform as a service on a cloud provider and how we did it, briefly. So basically you can see we actually did images on GCP, AMI, Amazon images, as well as Azure Container. And basically this is our state machine that does the machine learning. So I won't go into too much of that. You can do that offline if you'd like. Basically that state machine does the machine learning to learn the connection type and then feed it up in an image, and it's basically a system container image with the OS that's loaded up here. So the customer all he has to do is pick it, say I want to use CentOS or Ubuntu, click it and go, and it's already got acceleration built in, so they don't have to do any of the heavy lifting.
So is this baked in the image? Do you?
Yes.
Okay.
Yes. And so basically, here's how a user would have it. They could actually spin it up. They can put it in their automation. So a lot of times they'll put it into, if you're familiar with Amazon Lingo, their Lambda. So they can choose when and where to use it. But I'm sure with Google as well, you could write scripts as well, and Azure as well as OCI. Your automation document then feeds into the instance, loads the system container with the matched EC2, so you can pick your EC2 instance, small, medium, large, whatever you want. We support most of the images. You pick the regions you want to be, where you want to put it worldwide, kinds of backup and SLAs you want to have, and then it creates a whole new image all customized for you. It's all baked. Then you start applying it downstream to all of your end users. You can then also license it on-prem and then send it back up if you'd like as well. Another use case I thought I would point out is an SD-WAN use case, since Oracle just bought Talari, many of you are from Oracle. But also, this particular one is, you probably recognize it, I won't say who, it's not that one, but it's a fairly large one. But basically, because our code is so small, you can actually put it as a virtual network function in the universal CPE down here, okay? So you can run it as a virtual network function, call that acceleration, particularly when you're running a branch office where you might have a very slow internet connection. Maybe you're running DSL or cable, and then you're also bonding it with LTE, which is a very common use case for SD-WAN. So that way it gives you more pipe, because you can use both of the methodologies. Use our acceleration at layer 4 on top of those connections, and you'll get increased acceleration then over your bonded pipe to the internet or to any of your cloud services. And then of course you can match it up in the cloud. As I mentioned, we offer cloud images on many platforms. So you can then just spin it up and then send it back down. Or you can actually run it on your own data center server, right? And run it even over your private MPLS network if you want to. So there's a good example of how it can be used in a branch office to corporate office setting for enterprise. Of course, Oracle Cloud has a nice orchestrator, right? As well as you have Oracle Cloud over here, so you can see how you can spin it up on your Oracle Cloud workloads and accelerate your workloads down to remote offices, or even between branches, or even between your infrastructure centers. So with that, I wanted to leave some time for Q&A, but please check out our website, virtuosity.io. You can actually see our demo there. We've got a number of charts, white papers, test results, etc. And I believe we still have a 15-day free trial on our cloud offering if you'd like to try it as well. We also, the usual, click on LinkedIn, Facebook, Twitter. We're an Amazon partner, and we were just named the SDN networking top 10 networking companies of 2018. So please look at our website. And with that, thank you very much. I'll close it and see if there's any Q&A. Any questions? Suggestions?
Definitely want it on this guy. You should give it a try.
Yes.
Did you also have a slide on the comparison between the cloud providers you said?
Oh yeah, I can talk a little. Yeah, I'll talk a little bit because I
have
already wanted
experience
to.
with the three.
Yeah,
providers.
kind of the pros and cons. So we actually looked at all three of these to start with. We decided to go to move on to Amazon probably for a couple of main reasons. One was the, I guess the simplicity of being able to create a systems container. They were pretty early on the containerization, so that was nice. Had some very easy templates to do that. That's changing though, because now everyone's supporting Kubernetes and containerization on all the clouds. But at the time, because we did this about a year and a half ago, 2 years ago? 2 years ago, that was one of the big benefits. Second thing was their availability zones, because we had worldwide customers. So I needed to be able to put it in India, I needed to put it in Pakistan, I needed to be able to have people use it on Far East, right? And so they had some nice availability zones and reach that I couldn't get with some of the others. Specifically Azure and Google didn't have as much availability zone. I think you might have seen, was it last year, Azure had kind of a meltdown in Texas. That was because they didn't have enough availability zones. So it's very important that once you do go to cloud, you also think about the DR, the disaster recovery. I think the gentleman from University of San Diego mentioned that. Make sure you look at how you're backing that up, and that you have the right scripting and support language in there so that you can reroute things and also use multiple availability zones. Google Container, I'd say one of the reasons we ruled out Google was they were very good on the technical aspects, but one of the things that was really lacking was support. So when I tried to get phone support, it was very difficult. You'd be like, oh, I can't answer that, and I'd get passed and passed and passed and passed and passed. One thing I will say about Amazon support, $100 is $100, $150 a month for a startup, and within minutes of me putting in a ticket, I get a call back. Minutes. Sometimes I can't even get the thing down, my phone's ringing. So very good response, and they take ownership. So they will solve it. If they cannot solve it, they will get the person on that will solve it with you. So very good ownership model. With Azure, I didn't even get to the support issue because they wanted to charge me $15,000 a month. So that kind of put that out of order. Now they have changed their support models now. So I will say, in fairness to Azure, they've improved their network quite a bit, and they've dropped their pricing down to where it's fairly compatible with AWS relative to support. But at the time, 2 years ago, that was a big delta. So I just couldn't, as a lean startup guy, I was not going to spend $50,000 a month. I'd say the other thing, moving forward a little bit, that's nice about Amazon was, once you get your templates and you're already, your lambdas, all those things loaded, it's very easy to use across services. So for example, we use machine learning. Well, we have a lot of data that we collect on all these connections, so we need to be able to put it into a TensorFlow and be able to actually run regressions to come back with good models. So they have SageMaker, they've done some nice things there, so it's easy to port your data coming out of DynamoDB or S3 database, which are their two main brands, to be able to then automatically just flow that in to TensorFlow notebooks and then thus do your machine learning. So they're very good at cobbling together everything you need in one place. I'd say less so. Azure actually has some really nice machine learning technique, but it's very, I'd say, islandized relative to some of their other services. And we're not a big Microsoft Windows shop as well, so that was another reason I think we moved away from Azure in addition to the service. So those are just a few snippets as to why not. We're just N of one. The marketplace offerings, I would say, Amazon's pretty good about actually advertising and promoting for that. They're very good with startups. They actually offer $100,000 startup credit, which is pretty significant if you can, pass muster with them and become a partner. Google Container is a little bit further back with that. I'd say if you have your workloads ready and you know what you want, Google is much cheaper. It's much cheaper. I haven't looked at OCI in fairness, so I look at your costs. I definitely will go back and look at that because I'm always looking for better cost containment. That is one thing that Amazon is probably weak at, is that once you start to develop, it's like eating Lay's potato chips. You start eating and eating, and if you don't watch what you're doing, those expenses can start to add up quickly. So you really need to set those alarms. You need to build, set those up so that you get alerts and warnings and find out where those instances are that shouldn't have been running that are running.
Yeah, seen that.
Right. So that is I would say one of the weaknesses. So the power is in your hands. So you just need to make sure you get a good handle on it. That's one thing you have to watch out for.
Yeah, and as long as you're good about, like with OCI, you set the service limits and everything else, which makes it a lot more easier than because once you hit the service limit, then you get a call or you are not able to spin up something and then you ask questions and then you look at it. But that's precisely one of the things that we mentioned about hidden charges, right?
Right.
Or unpredictable charges sometimes.
Yeah, the thing about it is as soon as you may have, I only have 3-4 developers, so it's not like Oracle, you have hundreds of thousands of developers. So what's nice is you can then manage it at a master account level and you can see all who's running what, who's doing what, and it can be kind of daunting if you have, I can imagine if you have a large organization, but now there's a lot of third-party tools that will do that as well, but they will also, aggregate your logs and your trails and things like that. So, but that is one thing that you do have to watch, right? Regardless of which cloud provider you use, make sure you set that up well. I mean, I think routinely every couple months I'm getting an alarm and alert, looks like you're gonna reach, and it's proactive. It's not you've reached it, it's we think that you're going to reach this limit or overreach this limit. So please look at it now, don't wait until after it's hit that alarm. So that is kind of nice about Amazon. It will actually give you proactive estimates before it happens, as opposed to, oh, it happened, well then, geez, it's too late, right? Then I gotta argue about why I don't want to pay this, right? So just a few things, but is that what you're looking for? Yeah. Yes.
So do your clients, are they a part of your AWS organization, if that's how you have it set up, or do you set up an AWS organization for them that kind of encapsulates all of their AWS resources?
Good question. Yeah, so our VLAN cloud service is actually almost like a PaaS or a SaaS service. We do all that back office stuff for you. We containerize it. We make sure it's working on, compatible with certain kernel loads, certain operating systems, and then we just provide it as a service that you can just point and click. So that was the idea. That was hopefully our value that we had. And then Amazon pretty much is the channel partner. Their benefit, of course, is they get all the EC2 instances, that you all the compute that you have to use to run all of your workloads, of course, and this is a value-added service on top of it. But we have worked on premise customers. So we have a carrier operator, a large worldwide CDN that we actually did a proprietary image for them for their specific operating system, and then they run it on their edge cache servers. Similar to what Akamai does, but they've got a different one. But they've got 16 to 25,000 servers worldwide and edge cache. So we do that, but we usually aren't doing all that heavy lifting because we're small. But they usually will have a technical team that we can work with to integrate the algorithms and application into their operating system. We're doing that now for a mobile provider. We're talking to a cellular phone manufacturer as well, where they have proprietary images, right? They just don't have, Ubuntu off the GitHub. So we will do that. We've been pretty successful compiling it to most Linux distros and kernels. Good question. Thank you. Anything else? Yes.
When you do the machine learning, how much CPU does it take on the server side, maybe the cloud side? The other one is, if you have different people in the branch office and then they have different, browsing internet usage pattern, how do you know that some of them will not, for example, somebody's playing game or playing video, how do you know that they will not slow down by doing it?
Sure. Okay. So 2 questions. So just to, if everyone didn't hear it, one, I think the first question was you were asking about the application.
Machine learning, right? You say you have used machine learning, so how much does it take?
Yeah, how much CPU? So the actual CPU and the footprint of the code is very small. We're talking about less than a couple hundred lines of code.
But those code must be on the cloud, right? It's not on the client.
No, it actually resides, if they're running our cloud instance, it is in a system container, so it is running on the cloud, bundled with the operating system, because it's inside the kernel. If it's actually on premise, it would be the same thing, but on your own infrastructure, white box server, Dell server, HP, whatever you're using. And the actual processing time and the actual CPU and memory takes is minuscule. In fact, it uses no more or no less than the actual Linux cubic does anyway. So you're not losing anything when you move to our algorithm. In fact, if anything, you're gaining because we work better in packet loss situations in cubic. So it doesn't eat up any CPU or memory that you're going to notice. It's pretty much nanosecond. We can actually change, like you saw Chris was, if you're a Linux head, right, he was echoing and then changing the actual protocol real time live and then switching it and then running our acceleration. So you can do it like that. And with our machine learning, of course, it just does it automatically and can do it as fast as need be, depending on your network condition. Right? So if you've got a fairly clean network, you don't have a lot of packet loss, and you might want to calibrate it differently. The algorithm will calibrate differently. But if there's a lot of congestion, packet loss, then you probably want to run a different algorithm. Same thing like if you're running over a mobile network versus a wired network. So we have different calibrations that we have based on the data sets that we've been developing and the networks that we work on. Did that answer your question?
Yeah, but sometimes, as you said, sometimes it's a mixed environment. So even though you have these models, right? How do you? You don't want local people who doesn't know which one to choose.
Oh, okay, yeah. Let me answer that second question. So on the situation where I think what you're saying is this. Let me just back up. On premise, right? Like so, you could have hundreds of thousands of users down here. You're saying they could be using Google browser, Firefox, doing YouTube, doing email, whatever, right? The nice thing about ours is it's single-ended, so I don't have to have a client on this end. So my CDN, for instance, puts it in his edge cache servers. So everything that he sends to any users, the millions of users he has, gets the benefit of that acceleration downstream, because most applications, certainly consumer, are more downstream than upstream. But if you want upstream, as I mentioned, we do have an Android OS version, and we can do some integration with cell phones, where you would put it in the end device, and then you would improve upstream bandwidth, right? Because now more and more people are uploading videos, they're doing more peer-to-peer applications. So if you look at the US, our cell phone mobile networks are not very good on the upstream. You get way more downstream. It's asymmetrical, right? So being able to get that upstream, like my Facebook upload example that I showed you, right? That's why I did it. I said, hey, I'm tired of waiting I just loaded 25 pictures and a couple videos from my vacation, and it took me forever, right? So I put on my acceleration, and boom, got 2.5, 3 times faster.
So you can use it for security casual upload.
Yes, we have talked to some people that will want to use it to back up security video, right? Because you're putting big video clips and storing them up in the cloud. Yeah.
Thank you.
Do you plan to have it as a B2C offering as well?
We've thought about it. We actually, interesting you say that, we actually ran a Kickstarter campaign, built a little prototype device, got the campaign funded successfully, but we just decided it's too much for a startup to try to take on the consumer market. So we're actually looking for a partner, looking for a licensing partner where we actually built the platform up, put the acceleration in, and then provided a little prototype that you could build out, and then provide that to your end customers. So, that's licensable, but we decided not to actually implement the full SaaS B2C. That's a whole nother business. Great question, though.
Yeah, just thinking about how many people run their businesses out of Instagram and Facebook nowadays, right? And, so is it available as an app that people download and kind of helps, or is it, how does it work on the device?
Well,
I'm just curious.
Yeah, there's two ways. One way, you can integrate directly into the cell phone, so we're working with some cell phone manufacturers. The other way is with this little device we have. We prototyped it on a Raspberry Pi. It's an access point as well. I don't know, did you bring it?
Yeah, I have it.
Yeah. And basically, you connect it to your cell phone, right, using your LTE connection.
Okay.
And then you can transfer any of your video or data files through it and get upstream acceleration to a cloud. So we provide a cloud, like a Dropbox-like thing for you to place it, and then we can accelerate it downstream to wherever you want to send it. You just click on the link and do it. So this is an example of, it's a engineering prototype, but this is actual Raspberry Pi. And so you were asking about how much CPU. Well, this is running on what? ARM 5 core, it's maybe got like, I don't know, half a meg of memory on it. And and you saw the chart, right? We were improving our Facebook uploads by three times. So, this was our attempt at B2C, but we decided we just had to forego that because we're doing a lot of business-to-business licensing, and we're open to licenses, so we do have that on our website. So if anyone's interested, yeah, absolutely.
Very cool. I had to ask that question. It was just so obvious.
Okay. Last
What is the
question.
pricing model?
Excuse me?
What is the pricing model like for the cloud?
Pricing model, yeah. So you can go to our Amazon one, but I think it's like 7 cents per hour or something. And then you pick your instance of choice, right? You pick T2, free tier, you can pick XCX large, wherever you want. Yeah, and then we offer discounts for annual, right? So if you decide to run it all the time, you just want to set it and forget it, we give you, I think, 20-25% discount as well. So you can pay as you go, or you can do a bulk license, or you can do a regular on-premise license, and then you can put it on there and just do as many instances as you want, and it's yours, right? So those are our three models. Anything else? Oh, one more.
What is the maximum load you tested? Like say petabyte of data? Or is it
Good question. Yeah, I have not tried a petabyte yet. I will admit, we've not done that much. We've done some 10 gig tests, and that's about the max we've done so far. We do have one of the algorithms that's tuned for large payloads, particularly for large chunks of data like video files and things like that. But I would say we're not like IBM Aspera, if you're familiar with them. IBM Aspera has a proprietary way to accelerate. Like they do a lot of work with production movie studios where they send literally terabytes of video clips, right, east to west coast. But then they have to do proprietary, bookending in special servers and open source security for it, so you can get that acceleration. We don't do that kind of stuff. Ours is mainly mainstream, single-ended for a mobile operator or a CDN that wants to improve their downstream, a cloud provider that wants to provide accelerated edge cache, right? Any type of person, Facebook, that may want to increase the speed of their downloads or uploads to their customers. So those really are our targets. Okay, with that, I'll turn it over to you, back to you. Thanks for coming.
Thanks, Greg. So we have the room for another, actually up to 9 o'clock. We ended early today. So feel free to network more, and good to see you all. And we'll have again, in February, we don't have anything lined up right now. It would be great if we can have some speakers from our group who want to share their own stories or use cases about how they are migrating to cloud or the technologies you are using. I mean, a lot of people are interested in learning new technologies. So if you can share whatever you know, the new technology, or if you are interested in some topics, very interested in some topics, just either talk to me over here or post it on the discussions on our meetup site, so that I can try to get speakers on those topics. I mean, that's my best way to find out what you would like to listen on. So that's it. Thank you very much.
Thank you so much.